Hello, am I audible?
Yes, sir, you're audible, sir.
So, very good evening to all of you. So, today's
Good
session
evening,
is
sir.
about
Audible, sir.
solving session of week 11. So, hope you are familiar how to join this peer day. So, just enter on your browser joinpd.com. After that, you have to enter this code EQQEMK. So, please join it. After that, we will start the session.
Sir, I have not attended the hypergeometric and Poisson distribution. So this session will be helpful, or I have to first
Yeah,
watch that?
there is questions related to hypergeometric and Poisson, so you will get idea about that. So you watched the lecture video, right? Or not it?
All lecture except these two topics.
Okay. So you can cover up, right? Yeah. I mean, today there is questions in the slides. So all of you have covered the lectures video of week 11. I think Ritik is not able.
Yes, sir.
So you got the
Yes, sir.
concept. You are getting the concepts.
Yes, sir, but some confusions are there. So,
Okay, it's
little bit confusions are there. So, if you are gonna take some questions after the session, of course.
okay, we'll see, we'll see. We have to just
Okay.
read statement, each statement, and we have to think what's there. I mean, we'll see. No need to worry about that. Okay, so let me. Okay, so this is basically session for week 11. So this session. So those who have not joined it, just please enter joinpd.com on your browser. After that, you have to enter this top right corner code EQQEMT. Okay. So please keep a notebook and pen ready with you to solving the problems and all things. And according to the level of the questions, we'll allot some time and you have to solve within. You will solve the question within the given time. So yeah, you know how to enter this below corner code. There is a face where you have to write the answer. Okay. So should we start or there are only 15 participants? Just wait for a couple of seconds after that we start. Meanwhile, what is the, I mean, how will you identify the binomial random variable or binomial experiment?
If there are two
Independent and
outcomes,
identical.
Okay. Anything else?
and two outcomes should be there. Means
Two outcomes is for
two-
Bernoulli experiment also.
So the probability of success keeps remains same all through the trials, like independent and identical trials, basically.
if IID means identical, and what next? What was identical?
Independent identical distribution.
Yes. Independent identical, and it is Bernoulli, then it is also known as binomial.
Not a single Bernoulli known as binomial, and Bernoulli random variable will known as binomial.
Yes, sir, that kinds of confusion is still there. The intuitive approach. Sir,
Okay,
could you
we'll see,
suggest
we'll see.
any book or anything for that?
Book there is mentioned. I think you can do. I mean, you can. I think slides are and slides and lecture video are more than enough. But if you want, so you can do Google
Sir,
also.
actually,
You
problem
can-
solving type means derivation type things are understandable, but the intuitive approach means
Okay, okay,
that kind of is little lagging, sir.
okay, we'll see. I mean, there are questions you have to just identify. See, whether if you're doing any experiment. Okay, so for that only two things should be there: either success or failure, right? Okay, and your number of trials should be fixed. I mean, and your probability of success, what you want, whether you are interested in number of tails, whether you are interested in head, so that will be your success probability. Okay, I mean, according to the question, success probability can change. It's not about if you are tossing the coin, then always probability of head will be success probability. No, according to the in which you are interested, that will be success. Okay, there are questions.
Excuse me, sir.
Okay, yeah, yes, please.
Sir, I have tried one question from week 9 by using the IDD method, this Bernoulli trial.
IID.
Yeah, sir, but I wanted to discuss that question because I couldn't get the answer, because I know how to solve, but I tried with
Okay,
Bernoulli
after
also.
the end of this rest, we'll see
Yeah,
the rest of the
maybe we
questions.
can
Okay,
discuss.
yeah,
Yes,
yeah.
yes.
First, let's finish this.
Answer
slides.
expectation, because there is saying that if expectation is 250 of number of heads, so you would if you repeat means
Yeah, yeah.
500 times, then you will get 250 expectation. But previously
Yeah,
we have studied that expectation is overall average, sir.
I will tell you. I will tell you. Okay, there is question. See, one thing. Let me finish. After that, we'll start the session. Let me connect my writing device. See what expectation tells. Expectation of random variable tells you. Okay, anybody wants to tell him? No one. Huh?
Yeah,
Okay, see.
expectation
Yeah, yeah.
mainly denotes the long-term average.
Correct.
Like if the same experiment is performed for infinite number of times, or maybe long run, if we are calculating the sum of outcomes, or number of successes, or number of hits, I mean whatever the trial we define as success, so the long-term average will be calculated using, I mean, expectation gives the idea of long-term average. In long run, what will be the average sum we get, or what will be the average value we get? That is expectation.
Correct. See, basically, expectation is what? See, you have a random variable, correct? And
Yes,
suppose
sir.
you have random variable, so you will have some values for this, you will have some PMF for this, right? Correct. So suppose,
Exactly.
okay. So
Yes,
suppose
sir.
you want to summarize your random variable, okay, in a single number, rather than describing the whole distribution. Yeah, this is the PMF, this is and all things. Okay. So to summarize the random variable, and you are interested to summarize your random variable in one number, that means I can summarize in expectation. Okay, means expected value of this is this. See, what is the average tells you for a data? It gives you a central idea for this, right?
Yes,
So
sir.
same for the expectation of random variables. What see thing is that expectation is not a it's a something, you know, theoretical average, you can say. You can expect the thing, you can't say like so it gives you basically long run average. So what is the meaning of long run average? Okay, suppose tell me, you suppose you roll a die, how many outcomes you will get? 1 2 3 4 5 6, correct? What will be the expected value of x? It will be 1 by 6 for each, so it will be 1 by 6, 1 plus 2 plus 3 plus 4 plus 5. I mean 1 by 6, 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6. So you will get, I think, 10 15 15 18 21 by 6, right? Yeah, so 3.5. So here expected value of x is 3.5. So what is the meaning of 3.5? It means suppose you roll a die, okay, more number of times, okay, more number of times. Suppose you roll a die,
Yes, sir.
suppose 100 times, correct?
Yes,
Then
sir.
average of the results of the after rolling a die will be
That
close
would be
to
3.5.
3.5, will be close to 3.5. That's why it's saying it's a theoretical average and it's a long run average. Okay.
Yes, sir.
Get
That
it?
much I understood. But the means we are not expecting that 3.5 will be
No, you
outcome.
can't expect like you roll a die and I mean your outcome will be 3.5. that is the not meaning.
Yes, sir. But this context I understood. But if I roll a fair dice, means a question was there. If I roll a fair dice 90 times, and expected number of times 4 occur is 15, then what does this signify?
Where it is this question?
Activity 11.5, fourth question.
Have you attended the open session?
No, sir. Actually, that time I did not watch lectures.
Fourth question. You are talking 11.4?
11.5.
Okay. Suppose a fair die is thrown 90 times. The expected number of times of 4 occur is 15. What is the significance of the expectation? Okay. So what should be the answer?
It is option B. For it does not mean that exactly 15 outcomes will be 4. We can assume that, or we can expect 15 outcomes to be 4. It can be 13 or it can be 16, around 15.
Okay. That is the meaning of
but
expectation.
where the average concept came here, I did not get that. How to relate this?
Which average concept you are talking about? A long run average.
Yes, sir.
Okay, so that's why I say if you throw the die of 90 times, correct, for 90 times, then the outcomes of the each times, right? But first, second, third, fourth, up to 90. Okay, that
Okay.
if you will take average of that,
What outcome?
whatever outcome will be you will get after rolling a die. Okay,
1 or 2 or 6,
anything. Okay, that is the
Okay.
meaning. If you take the average of result of all the outcomes, you can expect 50.
Okay. But here we are counting 4, no, 15 times. This expectation is different. If we count 4, it might come 15 times. If we count
We can
3, it
expect
might.
15 of the outcomes to be 4. Yeah.
Expected number of times 4 occurs.
Yeah, correct.
But here we are choosing any random outcome, no, 1, 2, 3, 4, 5, 6. But in question
See
it is given.
what the given in the question also.
It
That
is counting the number of 4.
expected number of times a 4 occurs is 15. It given, right?
Yes, sir.
So that it's saying, see, suppose here expectation of x is, I'm saying 3.5.
Okay.
That what is the mean? Means suppose I roll this die up to 90 times, and I'm saying I roll a die up to 90 times, and expectation of getting a okay, expected value of x is 3.5, correct?
Yes, sir.
Then what does it mean?
It means whatever the outcome, we will sum up and find average. That is 3.5. Means 1,
Yeah,
2,
that
3,
will be
4,
close
5,
to
6.
3.5, correct?
Yes, sir.
So it's already saying, he's saying expected number of times a 4 occurs is 15.
So
You are
it
not
is
getting, right?
counting number of we are counting number of 4s. How many times 4? But we will count in every time 1 or 0, no? 1 or 0, and we will sum up to 15.
Why 1 or 0 here?
If one trial come 4, then we will count 1. If it is not, then we count 0. Here random variable is how many times 4 occur, no? So
Okay,
it can be 0 and 4.
Ritik, okay. Just let me finish the slides. We will discuss it because, okay. After the end of the slides, we will discuss the things.
Okay,
because we have to finish the slides as well. After the end of slides, we will discuss. Is that okay?
Yes, sir. Yes, sir.
Yeah, okay. So yeah, please, those who have not joined it, kindly enter on your browser joinpd.com. After that, you have to enter this top right corner code EQQEMK. Okay. So first slide is nothing but is basically a idea about solve the questions related to binomial distribution. So in this binomial distribution, you have to identify each trial and see whether you can classify it as success or failure. Okay, and you have to see whether the number of trials is fixed or not. If it's fixed, then it's okay. And you have to see each of the trials should be independent and identically distributed. Independent trial means each of the trials is independent of each other trial means suppose you roll a die, okay, and you rolling that die up to 3 times. So if you roll a die 1 time, so result of the result after rolling a die is independent when you roll die at the second time. Is that clear? And identical means probability of success should be same for each trial. That is the meaning. And if there is any experiment which satisfied all the above conditions, success or failure, and should be fixed, independent, identically distribution, that experiment is known as a binomial experiment. Okay, so
Sir,
simple things.
could you give an example that experiment is independent but not identical, and identical and not independent?
Okay, that's hypergeometric comes into the picture. Okay.
Okay.
Okay, see, suppose you have a bag. In bag, you have 3 red ball, 2 green ball. Okay, I'm saying you to draw the 2 balls without replacement. Then probability of success will be changed or not? It will get
Yes,
changed.
sir, but yes, it will be changed, but it will be both not independent and not identical distribution, right?
Sorry. Yeah.
Means this type of distribution will neither be independent nor be identical.
Correct.
I am saying, is there any example in which it is one of is true and one of is false? Means it is independent but not identical, or vice versa?
Okay. Okay, you are saying means its trials are independent, but
Yes, sir. Yes, sir, I can give an answer.
yeah, please.
Take
That
a coin and a dice. Roll a coin and throw a coin and roll a dice. On the coin, you define success as getting a head. Then what is the probability of success? We will be obviously 1/2. On a dice, you take the success as getting a 6. Then probability of success is 1/6. Though tossing a coin and rolling a dice are independent, one does not affect the other. The probabilities of success are different, right? So this is not identical. If we take these two together, those two actions are independent of one another, but since the probability of success is different, they are not identical. Sir, am I right?
are you getting
Yes.
Ritik?
So how many trials are there? 2 trials. One trial is
Okay,
die,
define how
and
we can define how many ever trials we want. Here, the probability of success is 1/2. There, the probability of success, that is P, it is 1/6. So obviously, not identical, right?
Okay. So yeah, Ritik, we'll discuss it. So are you? Did you get the point of?
yes, sir, I get
Okay.
it.
Okay. So now it's clear what is the binomial things. Okay. I mean, your number of trials should be fixed, and for each trial, I can classify it as success or failure. Okay, and trials should be independent and identically distributed. Okay, so let's move to the next slide. So this is the question number 1. You have given the 3 experiments. You have to identify which one is not a binomial experiment. Okay, so please, Amity, I think 1 minute more will be enough. If you want, I will extend the time. Okay, please do it.
Sir, press F11. It will be full screen.
Okay, so do you want extra time or everyone has done?
Finish, sir.
See the responses. Okay, so 10 people are saying option C, 4 option 2, and 3 people are saying option. Okay, so let's see. See, tell me. First option is tossing an unbiased coin for 100 times and counting the number of heads. Okay. So is this binomial or not?
Binomial, sir.
It's a binomial, correct? Why binomial? Because n is fixed.
N is
Number of
fixed, sir,
trials.
and yeah, it's fixed, and both the probabilities. I mean, not both the probabilities. I mean, it's consistent.
Correct.
Consistent. I mean, the
Probability
head.
of success. Yeah,
Probability of
same.
head.
Identical.
I- And
And they are independent as well of
they
each
are
other.
independent, correct?
Yeah.
Now, come to the second. Tossing a biased coin for 100 times and counting the number of heads.
No, sir, this is not binomial
This is not binomial.
because
So
the
this is
probability
also
of success is not consistent.
this is also binomial, right, sir?
Yeah, it's a
No, sir,
binomial.
it's binomial.
Sir,
Because
but if the coin is biased, then how can it be the? I mean, the probability of success will not be the consistent, na?
No,
why
see,
it won't be
okay,
Biased
okay,
means
consistent?
okay, okay.
probability is not
One
half.
second, 1 second. Okay, listen to me. Suppose your coin is biased. I'm saying probability of getting head is 0.4, right?
Yes.
Okay. Then
Yes.
if you roll a coin again, then you will again then probability of heads is again 0.4.
Okay. Okay. It will not be half, but it will be
Nah,
consistent.
yeah, correct. It
Okay.
should
Okay.
be
Okay. Clear, sir.
same for each trial. It's not like, see, probability of success same is for one trial
For
is
every
suppose it's
trial.
yeah, it's 0.4, then for second trial it should be 0.4, like that.
Yes, sir.
Okay.
Clear, sir.
And third question is choosing 5 balls randomly from an urn containing 20 yellow balls and 20 red balls without replacement and counting number of red balls chosen. Okay. So this is not a binomial. Yeah. First condition is clear. N is fixed. See, we have to see. We have to identify n is fixed or not. Second, probability of success is same or not. So here probability of head and tails are half because coin was unbiased. So each trial is independent and identical. In the experiment 2, n is again fixed. For each trial, if you get head, then it is success. Otherwise, it's a failure, right? So coin is bad. So probability of head can be C. I'm here. I have taken as C. I mean, it can be 0.4. It can be 0.6. I mean, whatever. Now, so this condition, probability of getting head as C, probability of getting tails as 1 minus C will be true, will be for all the trials. Okay. So probability of head getting as C will be same for each trial. Then it's a binomial. Now come to the experiment 3. Experiment 3 is saying n is 5 equal to fixed. So first criteria is satisfied, right? N is fixed here. But come to the next one. For each trial, if you get red ball, it is success, otherwise it's failure, right? Outcomes of each trial is success or failure. This condition is also satisfied. Now, for first trial, if what is the probability of red ball? 20 divided by 20 plus 20, because how many balls is there? There are 20 yellow balls, 20 red balls, correct? So in the first trial, okay, in the first trial, choosing a red ball will be 20 divided by 40, that is half. This is okay or not?
Yes, sir. Yes, sir.
Okay. 1 second. Yeah, 1 second.
So only third one is incorrect, right?
Yeah. So for the second trial, if you see probability of red ball, in the first trial, I have drawn already one red ball. So in the second trial, So probability of red ball will be 19 divided by 39, because one red ball is already picked up in the first trial, correct?
Yes, sir.
Yes, sir.
Now, thing is that here it's written as, one second. This last line you can see, are you able to see the last line? I mean, it's, yeah.
Sir, on joint PD, it is clearly visible.
Yes, sir. In joint period, it's clear, sir.
It's for, on screen you can see clearly, right? For you. One second.
So, sir, the bottom line is for the third case. If the first is yellow, it is changing, and if the first is red, it is also changing. So that's the thing, right? I mean, the probability of getting a red ball, it's changing for each case.
Correct. Let me share my screen. Yeah. So thing is that, see, you had 20 yellow and 20 red, okay? So in the first trial, suppose I draw a red ball, okay? Then probability for this it is 20 by 40, correct? What will be the probability in the second trial of drawing a red ball? It will be 19 by 39. Okay. When in the only when you have drawn a red ball in the first trial, suppose you draw a yellow ball in the first trial, then probability of red ball in the second trial, it will be
20 by 39.
So thing is that probability are probability of success. So here success is what I am interested in, the number of red balls, correct? Drawing in the red balls. So probability of success is getting changed in each trial, correct? So that means each trial is not independent and identical. So the last condition, IID condition, is not satisfied. That's why the third experiment is not a binomial experiment.
The key term here is the not replaced. I mean, without replacement.
Correct. If it will be replacement, then probability of success will be. Is this clear for everyone? We can move to the next.
Yes, sir. Yes, sir.
Yeah. So next is something you have to, I mean, the steps to solve the
Excuse
problem.
me, sir.
Yeah, yes,
Sir,
please.
if it, sir, this question was like, if it is without replacement, right? If it is with repetition, I mean, with replacement, then
Okay, suppose with repetition.
what will you say then? It's
okay. So what will the probability of red ball in drawing a first 20 by 40?
20 by 40, and again the 25 40.
So what is the success probability will be same for each trial?
Yes.
Yes, sir, please mute.
And there will not be any dependency.
So there is no dependency, in probability of success is same for each trial, right?
Yeah.
So that means it's a binomial. Okay.
So it's a
binomial,
right? Yeah.
Correct. Because n is fixed. I mean, if you draw a ball, then either it will be yellow, either it will be red. Correct.
So, sir, I think it's the key is we have to find whether it is dependent. There is any dependency.
Correct.
It's the key.
Correct.
Right. Yeah.
Suppose you draw a yellow ball in the first trial, probability of success is 20 by 40, right?
Yeah.
And you draw in the second trial, what will the probability of red ball? Again
It will be
20
the
by
same.
14,
Yeah.
because I'm replacing the ball. Okay,
Yes.
correct. So
Yeah.
that is the key thing. You have to identify each thing, whether n is fixed, first step. Second, you have to identify the outcomes of the trial is, you can either classify in two things. I mean, either it's a success or failure. Third is you have to identify independent and identity. Okay. Now, suppose something steps to solve the problems. You have to identify the things like to calculate the probability P of the given statement. So you have to identify the binomial random variables and number of trials, as we have discussed. We have to check whether it satisfied all the properties of binomial random or not, and we have to note down the this expression. So for the binomial experiment, probability of x equal to I means x, what x is here? X is nothing but number of success, correct? So suppose for getting ith success, probability for getting ith success is nothing but NCI p raised to power I and 1 minus p raised to power n minus I. So this is the PMF formula for the binomial experiment. Okay, you know, by
Sir,
Bernoulli is there something. One second. So Bernoulli trial is, suppose x is the random variable xi. Okay, so for ith random variable, Bernoulli is what? You will get 1 or 0, correct? 1 with success probability p, 0 with success with probability 1 minus p. So when there are n Bernoulli independent trials, okay, this will make the binomial random with parameters n, comma, okay. That's why, see, what is the expectation of Bernoulli random variable? You know, it's a p, 1 into p plus 0 into 1 minus p. Okay, if it's independent and all things, if you apply the expectation at this whole summation, that means expectation of x1 plus expectation of x2 plus so on expectation of xn. So p plus and so on and p. So it's a
N
np.
into P.
So this is the mean of the expected value of a binomial random variable. So binomial is nothing but the sum of n IIT Bernoulli trials. So let's move to the next slide. So next slide is this is the question, and sorry, trainer wants to test the skills of new joint issues. Okay, yeah, which includes some uh, prodigies. Sorry for that. Skilled or talented. So the trainer puts up circular board of radius 20 meters. Okay, and if students shoot an arrow in the region of radius 5 meters, then the trial is considered as success. So here it's mentioned what is your success here. If the students shoots that arrow in the region of radius 5 meter, then that things is considered as success. Otherwise, it will be failure. If it's outside 5 meter radius of 5 meter, okay. And the students undergoes 3 trials, need to get at least 2 success out of 3 trials to pass the test. Okay, so you have to find the probability that a normal students will pass the test. Assume for a normal student there is equal chance that arrow will land anywhere on the board. So I'm going to give the 3 minutes. After that, if you feel, will increase the time. Okay, please do it. And those who have not joined yet this peer deck slide, kindly enter the joinpd.com on your browser. After that, you have to enter this top right corner code EQQEFK.
Sir, 30 seconds more.
So I have received only 10 responses. So I'm going to give one more minute so that everyone can see. Everyone got the question, right?
I got, sir.
Done, sir.
Okay, let's wait for some 38 seconds, 37 seconds. Okay, so is there anyone who wants to some extra time? See, if you will not respond, then we'll log this. Okay, so let me see the responses from the 0.33. Someone has entered 1.12. I don't know how, as binomial cannot exceed, I mean, binomial, no, I mean, probability cannot exceed 1, right? So all the answers are different.
Sir is more than 100% sure.
Okay, so thing is that in this question, you have a circular board. I mean, trainer puts up a circular boards of radius of 20 meters. Okay. So, sorry. So what is the experiment is here? Shooting an arrow onto the circular board. Okay. So what is the success probability? When you will get success? Success means when a student shoots an arrow in the region of radius 5 meter. Correct. Otherwise, if it lands elsewhere, then it's a failure. So far, it is clear. It's
Yes,
clear
sir.
for correct. Now, so you know what is the area of a circular of radius r? It's a pi r square. Correct. Now, so area on the circular board which leads to success means pi r square means when it's of the less
Radius is
than
5.
radius 5 meter, right? So it will be pi into r is here radius 5. So r will be 5. So it will be 25 times pi. Correct. What is the total area? It's a 20 meter radius of 20 meter. Correct. So total area will be pi r square. So pi r is here 20. So it will be 400 pi. This is the something favorable case and total case I have identified. So what's the probability of success? So it's a success area divided by total. So it will be 25 pi divided by 405, which is nothing but 25 divided by 400. So far it is clear for everyone.
Yes, sir. 1/16.
Okay,
Yes, sir.
it is clear for everyone till now.
Yes, sir. Up to this,
Okay.
we have done, sir.
Okay, now next question, what question is saying, I got the probability of success as 0.0625, probability of failure will be 0.9375, which is 1 minus. In the question it said students undergoes 3 tasks. I mean he has 3 tasks, so n will take value 0, 1, 2, 3, correct? So he has 3 trials. X is defined as the number of success among the 3 trials. So I know the PMF of binomial of getting probability of getting I success among the n trials is nothing but the n choose I p raised power I 1 minus p raised power n minus I. Okay, but in this question if you see it said student need to get at least 2 successes out of the 3 trials to pass the test. What is the probability that a normal students will pass the test? So to find the probability the students will pass the test, that means what we have to identify there, what values x will take here.
2 and 3. 2 plus 3.
2 and 3.
It is asking about at least 2, that means I can say probability of x greater or equal to 2 I have to find.
Yes.
Correct, because in
Yes.
only then that students will win the that test. So probability of winning means it's nothing but probability of at least 2 out of 3, correct? Here probability of that means x is greater or equal to 2, that means and I know x is taking the value up to 3, right?
3. Yes.
So it will be x equal to 2 plus probability of x equal to 3, and I know probability of x equal to I is nothing but NCI p raised power I 1 minus p raised power n minus I. So it will be NC2, I mean instead of n it will be 3C2 p raised power 2 1 minus p raised power 3 minus 2, it will be 1, and 3C3 p raised power 3 1 minus p raised power n minus I. So 3 minus 3 will be 0. Okay, so yeah, so that is the something we have computed. If you calculate the value you will get the answer as 0.011. Is this clear for everyone?
Yes, sir.
Okay, see here probability of success was not given directly. You have to find the probability of success, like see if you roll the die coin, you will get head or tail. Okay, so what the probability of getting a head? Suppose getting head is a success, so what is the probability of getting head? What is the
Half.
favorable case? 1.
Half.
And what is the total case?
Sorry, 1. Yeah, half. Yeah, total half.
Yeah, half. I mean total is half, I mean. Okay, so here thing was that total region was 20 meter. Okay, so what is the total area? 20 pi square, correct? No, sorry, pi into 20
pi into
square,
20
20
square.
square pi.
correct? And the trial will be considered as success when it will be within the 5 meter radius will be 5 meter. Okay, so what is the favorable case? This pi.
5 into 5.
So this is the probability of success here. Okay, is this clear for everyone? So that then we can move.
Yes, sir.
Okay, yeah.
Yes, sir. Sir, everything clear, but I have a doubt regarding notation. We are using xin bin, then xn bin. This type of notation are confusing. There are several type of notation.
No, it's a simple things, right? See, combination things. Suppose, see, just go with the concept, right? What is x represent? Number of success. Okay, so probability of getting, I'm saying I success.
No,
that means
no,
n.
this much notation I clear, sir.
Hmm.
The notation of denoting Bernoulli bin. Sometimes we use xn bin, sometimes we use xnb, and sometimes we are
It's
using
anything. You can write.
xib.
You can write x follows binomial. You can write x
Sir,
follows.
this is n or another symbol. X binomial, between x and binomial.
This is right.
Yes.
Yeah,
Sir.
this is something tilde sign. Okay.
Okay.
This
Okay.
means x follows binomial.
Okay. X is a random variable which is follow binomial.
Binomial, correct.
And xi follow binomial.
Xi.
Yeah, in subscript, in down script, we are writing I.
So you can write down like this. It can be anything,
This is
right?
also a notation X I follow bin.
See, it's not a fact like you have to write this like xi followed. Why I can I have write xi. Suppose I have x random variable. Okay, forget about it. Suppose I have an independent Bernoulli random variable. So
Okay.
x1 is a Bernoulli random variable, x2 is a Bernoulli random variable, x3 is a Bernoulli random variable, up to xn is the Bernoulli random variable. Then I will say in general xi follows. I mean xi is the something Bernoulli random variable. Okay, and I will goes to 1 to n. I mean it's a convenient notation. You can write it down. Okay, it's
And
not.
if we write only B, then what does that represent?
No,
X follow B.
no. If you can't write in, I mean if you write as B, then you have to. I mean clearly mention what you mean by that B. Okay.
Okay.
Sir, did the question ask probability or percentage, sir? Actually, I missed it.
Okay, it's a probability. I mean, we have it bet next one percentage. You can convert in percentage also.
Yeah.
I think that's why someone has entered 1.12, right?
I am
Yeah, I think.
thinking whether I have missed it or the question specifically
No.
asked what is the percentage.
Question was about probability. Okay, so we have mentioned the. I mean, you can
Probability.
convert this probability in percentage also, right?
Yeah, yeah. I was confused since here 1.12 was mentioned.
No. Okay, so next slide is about step to solve another type of question. Okay, so thing is that you have to identify the binomial random variable as usual. Now, use the, what is the expectation of binomial random variable is NP, and variance of a binomial random variable is NP into 1 minus P. Okay, where N is the number of tries and P is the probability of success. And 1 minus P, sometimes we denote it as Q, which is known as probability of failure in a trial. Okay. Now, so suppose expectation of X is given to us, variance of X is given to us. Okay. And it is asking about unknown values of N and P. Correct. So then by using these two equations, I can find out the value of N and P or not. Suppose you have two variables, two unknown things, and you are given the two equations. With the help of those
Yes,
two
sir. Yes, sir.
equations, I can find out the value of those two unknowns.
Yes,
Yes,
sir.
sir. Yes, sir.
Yes,
Okay.
sir.
Variable
Two
equations.
unknown,
Yeah.
then two questions.
So that is the something here, and we can use this value of N and P to answer the given question of question of getting the number. Okay. So let's move to the next question, which is question number 3. So here variance is given to you, expectation is given to you. You have to find the probability of getting 3 tails. So what's the probability of success here? I mean, what is the success? Getting tail or getting head?
Tail.
Tail, sir.
Tail, correct? Yeah. So it can change. Sometimes people will think like, yeah, getting head. I mean, head is always success. No, that's not me. Okay. So yeah, please do it. I think you understood the question. So another 1 minute will be more than enough, or 3 minutes? So do you want extra time? I have received only 10 responses. Let me give another 30 seconds. So should we see the answers?
Yes, sir.
Yes, sir.
Yes, so 0.3087, 0.3087, nice. Okay, nice, nice. Someone is enter 0.27, 0.75. Let's see what we get. So here variance and expectation of getting number of trials in tossing a biased coin is given to us, right? So biased coin is probability is not half, correct? So
Yes, sir.
variance, yeah, variance x is the binomial random variable that represents the number of trials here, correct? And number of trials and probability of success, let and number of trials as and probability of success, which is getting a tail is p. So expectation of x is what? 3.5 given to us. Variance of x is given to us 1.05. Now we have to find the probability of getting three tails. So what is the probability of getting three tails? Okay, so it should be nc3 p raised power 3 1 minus p raised power n minus 3. Okay, but we don't know what is my n, what is my p, and we are given expectation of x as np as 3.5. Variance of x as np into 1 minus p is 1.05. So with the help of these two, I have to find the n and I have to find p, and we have to put the value here. Okay, is this okay for everyone?
Yes, sir.
So how we can find the value of uh, n and p? See, we have given the value of np into 1 minus p. So 1 minus p will be 1.05 divided by np or not? Correct. So 1 minus p will be 1.05 divided by value of np, which is 3.5. So we will get value of 1 minus p as 0.3. So value of p will be 0.7. Correct. So we got the success probability. Now we have value of p as 0.7. When you will put the value of p 0.7 in equation 1, I will get value of n as 3.5 divided by 0.7. Correct. So n is 5. So probability of getting three tails in 5 tosses, it's nothing but 5c3 0.7 raised power 3 0.3 square. ncx, n is 5, I is 3, p raised power I, p is 0.7 raised power 3, and 1 minus p raised power and minus I, which is 5 minus 3, which will be 2. So you will calculate, you will get the value as 0.3087. Any doubt in this, or is clear for everyone?
Clear, sir.
No, sir. Clear, sir.
Let's move to the next slide. Again, something steps. Thing. Yeah. So you have to identify the event of success and failure, as usual, what we are doing in the binomial random variable. Then you have to identify the total number of trials. It's something steps to solve the question. Next question. And I know the formula of getting I success among the untrials is nothing but, I know this is nothing but the PMF, which is probability of x equal to I. We know n choose I, p raised power I, 1 minus p raised power n minus I. So I have formula probability of x equal to I. So I can identify the value of p. Suppose you have given the value of n, you have given the PMF, and by finding the value of p, I can give the answer of, see, suppose PMF is given to me. Okay, PMF is n choose I, p raised power I, 1 minus p raised power n minus I. This is something value, let's say it's a, and n is given to us. So I can find out the value of p or not?
Yes, sir.
Okay.
Yes, sir.
On
If
the
I is
behalf of
given.
those value, the value of p, I can give the answer of the given question. Okay. So this question is based on the some previous. And so question is, Ritika wants to test whether the coin she has is a fair coin or not. So to test this, she conducted an experiment of tossing the coin 4 times. So what is n is 4. Binomial random variable x is defined as the total number of hits after 4 tosses, and PMF is given to you. It is asking about what is the probability of getting a hit. So I have n, I have PMF, but I do not have value of p. Okay, so first find the value of p, and you have to find the probability of getting a head. Okay, don't get confusion like x equal to 1. So probability of getting a 1 here is, I mean, is directly, you can say 0.3456. It's a PMF is given to us. Okay, I mean, when, so question is clear for everyone? We give 3 minutes so that you can solve the questions. So I'm going to give one more minute. So do you want extra time?
No, sir.
Done, sir.
Okay, so let me see the responses. 0.4, 0.4, 0.4, 0.6, 0.4, 0.3456. Okay, so in the question, Ritika tossed a coin 4 times, so I have n as 4. Okay, so in this such scenarios, okay, when PMF is given to you, okay, and you have to find the value of P. So extreme situation, I mean extreme values of X is good approach to solve this. Okay,
0.4.
okay, so suppose I have to find the value of P. So let's take extreme. I mean you can proceed with either X values taken as 0 or X value takes as 4. Okay, then you will get a simple equation. Okay, otherwise what will happen when you will take X equal to 2, you will get P square 1 minus P square something. X equal to 3, you will get P cube 1 minus P. So you will get some complicated thing, but you will take, when you will take extreme cases, you will get simple equation. So let's take X equal to 0. So X equal to 0 is given to us 0.1296, correct? So 0.1296 is given to me. X equal to 0 means what? 4C0, P raised power 0, 1 minus P raised power 4 is given to us, correct? So it's a 0.1296. So P raised power 0 means 1. 4C0 will be 1. So 1 minus P raised power 4 is 0.1296. So I can do 1 minus P square is nothing but 0.36. Okay. Similarly, you will get 1 minus P as 0.6. Either you can proceed with the when X is taking as 4. So 4C4 P raised power 4, 1 minus P raised power 0 is given to us 0.0256 from this PMF table. So P raised power 4 is 0.0256. So I can write P square whole square, right? As here I can write 1 minus P square whole square. Then square of the 0.1296. This is the square of the 0.36. So here from here I got P square as 0.6. So P is the 0.4. Here 1 minus P is the 0.6. Till this point, it's clear for everyone, or any doubt?
Yes, sir, clear.
Is clear?
Yes, sir.
Okay.
Yes, sir.
Come to the next. So that was the one approach. Okay. Another approach I can do, I can have the expectation of X or not.
Yes,
See,
sir. We can evaluate. We can multiply.
correct. I have NP. I can find out the NP, and I know the N. So with the help of, suppose NP is coming out to be here 1.6. So N is 4. So P will be 0.4. Correct.
Yes, sir.
So
This is new.
this, yeah, this is the two approaches. So you can proceed with any one of these. Okay, is this clear for everyone, or any doubt?
No, sir.
Clear, sir.
Yes, sir. Yes, sir.
So let's move to the next slide. So next is nothing but, as usual, you have to identify the N, and suppose variance is given to you, and using the value of variance and N, I can find the values of P. Are you getting my point? See, variance is
Yes, sir. Yes,
given
sir.
to us np into 1 minus p. Suppose it is given to us as a. N is given to me. So I can find out the value of p.
Yes,
Correct?
sir.
Yes, sir.
So that is the something relate to the next question. So if you will get more than two values of success probability p, so kindly enter the values by comma separated. Okay, so I think 3 minutes will be more than enough for you. So do you want extra time? As I have received only 7 responses, so
No,
I'm going to
sir.
give.
So 30 seconds, sir.
30 seconds will
Okay,
be.
okay, fine, fine. I have given 1 minute. I think you are saying maths 1 is has dedicated big bar of 412. I mean division. I mean what?
Mm, Will we stats will be also such thing
For
after
revision
2
session.
December? Yes, sir. After 2nd
So
December.
that's, please check your calendar. Session has already planned. Okay. Okay, so 0.4, 0.6, 0.4, 0.6, 0.6, 0.4, 0.2. How 0.2? Okay, that's nice. So variance of a binomial random variable for n equal to 8 is given to us as 1.92. We have to find possible values for p. Now, so n is 8, variance of x is 1.92. So what's the variance for binomial random variable is np into 1 minus p. Okay, and np into 1 minus p is nothing but is given to us as 1.92. So n is 8, p is, we have to identify. So 8 into p into 1 minus p is the 1.92. So p into 1 minus p equal to 0.24. Okay, because 1.92 divided by 8, it will give you 0.24. Okay, so far it is clear for everyone.
Yes, sir.
Now
Yes, sir.
come to the
Yes,
next.
sir.
So p into 1 minus p as 0.24. So I can write p square minus p minus 0.24 is equal to 0 or not? I
Yes,
can
sir.
write,
Yes, sir.
correct?
Yes, sir.
So this is nothing but the equation we have to,
Quadratic.
quadratic equation we have to find out the values of unknown. So p square minus p, so 0.24 I can write 0.6 into 0.4 equal to 0, correct? So point, and for p I can write it as 0.6 p minus 0.4 p or not, because p is something minus 1 times p. Okay, so this minus p I can split in 0.6 p in minus 0.6 p or not. Are you getting this point?
Yes, sir.
Yes, sir. Yes.
Is it okay for everyone, or should I write it down?
Yes, so it's clear.
Sir,
It's
we
clear?
can use the minus b plus or minus b square minus 4, that we can use and directly solve, right?
Yeah. So here p I can take as common, so p minus 0.6 p. So from this terms I can take 0.4 as a common, which will be p minus 0.6 equal to 0. So it will be p minus 0.4 and another will be p minus 0.6. So from here p is nothing but 0.4 or it will be 0.6. Okay, if you, okay, so if you will take 0.4, 1 minus p will be 0.6. If you will take p as 0.6, 1 minus p will be 0. Okay, so here we got the values of p, which is 0.4. Okay,
Yes, sir. Before solving quadratic, we could also get 6 and 4 times 24.
yeah, you can also get here. I mean, this is something you can do by hit and trial. I mean, see 0.24, it's easy. Suppose it's 0.1123, then I mean
11
again,
times 11.
yeah. So you have to think
Actually, that is
accordingly.
1 to 1.
Okay, is it clear for everyone?
Yes, sir.
Yes, sir.
So let's move to the next slide. So next slide is about, yeah. So this is the something twist. I mean, not twist, you can see. So you have box. This question, if you remember, this question was also in week 10. But thing is that you have to identify the distribution. So question is, there are 10 chocolates of which 6 are milk, 4 are dark, 2 chocolates are drawn at random without replacement from the box. Then what is the expected number of dark chocolates drawn? So I'm going to give 1 minute will be more than enough. Let me give 3 minutes so that everyone can solve. Okay, so please do it. Okay. Okay, so do you want extra time?
Yes, sir. 1 minute, sir. 1 minute.
Okay, okay, fine. Is it done or in extra time?
Done, sir.
Sam?
Done, sir. Done, sir. Done, sir.
Okay. So let me see the responses from your side. So 0.8, 0.8, 0.8. Okay, 0.8.
Sir, I made
So,
tree diagram.
okay, that's also correct approach. So how did you do? X, there are 10 chocolates, of which 6 are milk, 4 are dark. So 2 chocolates are drawn at random without the replacement from the box. So we have to find the expected number of dark chocolates. Okay, suppose there is 2 approach for this. X is expected number of dark chocolates. 2 dark chocolates are drawn. So what, I mean, no, 2 chocolates are drawn at random. So what possible values X will take? 0, 1,
And
2.
2.
Correct. How many
2.
chocolates are
Yeah.
there? 6 milk, 4 dark. Okay. So
Four
out of
dark and
10,
6 milk. Yeah.
6 milk and 4 are dark out of 10. So what will the probability of X equal to X mean? What will the probability when X equal to take 0? 0 means when there is no dark chocolates. What
So,
will the
Or
probability?
so
10,
it
sir,
would
we will
10
choose
C2 and over up over there 6 C2.
62 because there is 0 dark chocolate. So we have to select 2 chocolates from the milk. What will the probability for one?
The 6
Means
C1 into 4 C1 divided by 10
correct.
C2.
Yeah, one dark chocolate means another dark chocolate is the milk one divided by 10 C2. Correct. What about 2? Means both are dark chocolates divided
Dark
by
chocolate 4 C2
10
10
C2.
C2.
So expected number of X will be 0 into this probability plus 1 into this probability plus 2 into this probability. This is the one approach. Another approach is I have total and as a 10 chocolates, out of 6 are milk, 4 are dark. Correct. What is the X? X is the number of dark chocolates. Correct. That means I can say there is m objects of one kind and capital N minus F small m objects of another kind. Means m objects, I mean 4 are dark. That means 10 minus 4 are 10 minus 4 is 6. So 6 are milk and I'm drawing a sample of 2 chocolates. Correct. So without replacement. So is which distribution it follows?
hypergeometric.
Hypergeometric.
It's a
Hypergeometry.
hypergeometric. So what is the expected value of hypergeometric? It's n into m divided by capital N. Correct. So n is 2. M is one kind. One kind means in which you are interested here. We have to identify the expectation of dark chocolates, right? So here m will be 4 divided by 10. So 8 divided by 10, which is 0.8. Is it clear for everyone?
Yes, sir.
Yes, sir.
Yeah,
So this is
sir.
the something hypergeometric means you have, okay, you know the hypergeometric concept.
No, sir.
Okay, so hypergeometric random variable is nothing but, suppose I have something, these things, okay, and suppose I have total n, capital N balls, okay. Of this capital N balls, suppose small m are red balls, okay, and then remaining ball I'm taking as, let's say, yellow,
Another color.
another color, okay. So out of these n balls, m are one kind, n minus, okay, let and write down outside. So out
We
of
can
these
also say
n,
non-red if it
yeah,
is
non-red,
multiple
yellow,
color.
anything, it can be anything, okay. So m is one kind and remaining is another kind of object, okay. And I have to draw a sample at random of size n without replacement, correct.
Yes, sir.
Then probability, and suppose x is what is, suppose I'm interested in number of red balls, okay, red balls selected, and I'm choosing the n balls without replacement, okay. So probability of x will be what, suppose I'm taking as I, you can write it down I. So what is the probability of choosing I ball without replacement from this? It's a simple thing, right? So I'm choosing, what is the total case here? I'm choosing small n balls out of this capital N balls, right?
Yes,
It's a
sir.
simple probability which we have done in the week 7 and week 8. So total case is NCN, correct? Now, what is the x?
Number of case.
X is number of red balls, right? And I want to draw, I want to select I red ball, I number of red ball. So in how many ways you can select I red ball?
MCI.
MCI, correct? And
Yes, sir.
remaining, see, since we are drawing small n in total, so we have to draw small n minus I balls from remaining n minus m object. So this is the PMF of the hypergeometric distribution.
Sir, you have explained this PMF in 2 minutes only. I understood it absolutely.
So it is clear for everyone?
Yes, sir.
Okay. So expectation of hypergeometric random variable is nothing but n into m divided by capital N. These things you can, if you know, so you can directly tell, identify the answer. If you don't know the formula, then you have to approach this way. You will get the.
And how do you get, sir, that expectation?
There is a derivation, it's discussed by the lecture. Okay. So the derivation, you can watch the lecture video. And suppose, yeah, okay, let me give another example. Suppose I have, let's say, 11 member, okay, out of which, let's say 3 are boys, okay, and let's say 4 are boys, that means 7 are girls, okay. And suppose
Yes,
I'm
sir.
going to choose three uh, students. Suppose these are 11 are students, and I'm going to choose 3 students from these 11 at random without replacement, okay. So tell me, and suppose x is represent the number of boys selected, okay. So what is the expected value of x?
By your formula, you have said n times m.
So n will be 1 minute. N
N
will
is n is the number, n is the sample which you are choosing at
3
random.
times.
three, right?
So its formula is n times m divided by capital N. So be
Yes.
clear with the
Capital N
notations.
will be clear 11.
Clear 11, right?
Yes.
M is nothing but m. See, be clear with the small m. Small m is nothing but the object of one type. Object of
So that
one
is
type.
boys.
Okay, and that is, here I'm interested in number of boys, so let's take m is as a boys, correct. So m is the number of boys, so n minus m will be number of girls, okay. So it will be 3,
3
as I'm
into
choosing
4.
the 3 into 4 divided by 11,
Yes, 12 by 11.
correct. It is clear for everyone. Either
Yes.
this you can approach in this way, or I know I'm choosing the 3 3 students, so my x will take value 0, 1, 2 and 3. And since probability of x, you have to identify the probability of 0 boys, so it will be 7c3 divided by 11c3, 1 boys 4c1 into 7c2 divided by 11c3, and so on. You can you can find the expected value of it. Okay,
Yes, sir.
it's clear for everyone. Is it clear or any doubt in this?
Yes, sir. Yeah,
Clear?
clear, sir. Clear, sir.
Oh, okay. Thank
Yes,
you.
sir.
Yeah. So this is the solution which we have discussed. So here, capital N is total number of chocolates. Small m is the number of dark chocolates, and small n is the number of chocolates selected. Okay. So do we move to the next question?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
That is
So
last question, I think.
yeah. So next question is
Testing.
based on the Poisson distribution. This is a very simple question. Okay, so please do it. I think 3 minutes will be more than enough.
Sir, mean is expectation.
Yeah, you can interpret that. Yes, so do you need extra time or is this done? Hello, am I audible? Right?
Yes, sir. Done.
Yes, sir.
Oh,
1 minute, sir.
okay. So you want one? Okay, let me give. Is it done?
Yes, sir.
Okay. So let me see the responses first. So 0.223, 0.513, 0.223, 1033, 0.23, some uniformity, some. Okay, so it's a direct thing, right? A car firm has two cars, which it has out day by day. It's saying the number of demands for a car on each day is distributed as a Poisson distribution with mean 1.5. Okay, so it's saying we have to calculate the proportion, or you can say we have to calculate the probability of days on which neither car is used. So tell me, as we know, lambda is a parameter of Poisson distribution. Okay, and mean and expected value of random variable is also known as lambda. So mean and variance is same for Poisson random variable, correct? So that means here lambda is 1.5. It's given already, correct? So PMF of Poisson is nothing but probability of x equal to x. Suppose probability of days on which x demands for a car is given. So it will be given as probability x equal to x. It's a PMF of Poisson is e raised power minus lambda. Lambda is for x upon x factorial, and x takes value 0, 1, 2, and so on. So it is asking about probability of days on which neither car is used. Neither car is used means when x demands for a car, I mean 0 demands for a car, then probability of x equal to 0 will be e raised to power minus 1.5 into 1.5 raised to power 0 divided by 0 factorial. So while, and we know one something raised to power 0 is 1 and 0 factorial is 1. So it will be e raised to power minus 1.5, which is you can calculate from the calculator, which is nothing but the 0, I mean 0.223. So this thing is clear. It's a simple direct thing, right?
Yes, sir.
Okay. So can you tell me in which situations Poisson rank distribution, for what situations Poisson distribution came? Okay. So
Sir,
far it's
could,
clear for everyone. These things.
sir, could you explain as you have explained hypergeometric?
Okay. Okay. I will explain. This thing is clear for the rest of the people.
Yes, sir.
Okay. So there is very interesting slides, as we know. It's about
Thank you,
you.
sir.
Yeah. So yeah, let's discuss the Poisson. So anybody wants to tell what is the Poisson random variable, as binomial distribution comes into the picture when I have independent trials, and each trial there are two outcomes and should be fixed. Probability of success should be same for each trial. In those scenario, we have to apply the binomial. Hypergeometric, there are situations for hypergeometric where I have total number of items as n. There are m types of and m items are one type, n minus m item will be another type, and I want to choose a sample of n items without replacement. Then what is the PMF? So in this situation, hypergeometry comes into the picture. So for what Poisson distribution? Anybody wants to tell?
Sir,
When
it
the
is
number
for
of yeah,
Yeah, please, one by one. Yeah, it's okay. Yeah, anyone?
It is for number of trials. When the number of trials is large and the probability of success is so small, then Poisson distribution comes into picture, I think.
Okay, that is the something approximation of Poisson to binomial, right?
Yeah, and sir, actually Poisson is
Please go ahead.
is used when the events occurring in a fixed interval of time or space.
Okay.
When we have a fixed interval of time, like per day or something like that.
Yeah, in a, you can say time space, right?
Yeah, fixed time or space.
Like that. So you can say, okay, suppose what we are doing in the binomial, see, in the binomials, we are interested in outcomes of a definite number of trials, right? In the Poisson distributions occurs when there are events. Yeah, please listen to me. When there are events which do not occur at outcomes of a definite number of trials of an experiment. Means, see, suppose the Poisson distribution occur at random points of time and space, right? Suppose I'm interested in at random points of time and space, okay, where
Yes, sir.
our interest only in the number of occurrences of the event, not in non-occurrences, where I can see, you can write our interest lies only in the number of occurrences, okay, not in its, you can say, non-occurrences. Okay, so thing is that Poisson distribution occur at random point of time and space, where when we are interested in at a points of time and space, and our interest is the is lie in the number of occurrences. I mean, are you getting this point, or I think it is creating a problem? I will give the
No,
example.
sir, I
I
am
think,
getting time, sir.
I think okay. Suppose
It is just like that previous one. We did not define that this number of time or that previous car question, right, sir?
yeah. So in the previous car question, what we have done. See, now let's say I'm going to give an example. Let's say suppose I'm interested in number of suicides reported in a particular city. Okay.
Yes, sir.
So what is this? We are
Suicide
interested in
random.
number of occurrences, means number of suicides. Let me write this example: number of suicides reported in a particular city. Okay. Now, so what is this? Here we are interested at random points of space, not time. I'm interested in space, means in a particular city, what is the number of occurrences? What is the number of suicide reported in a particular city? Correct?
Yes, sir.
Another example I can take, like yeah, number of, you can
Sir, it
say,
should be in a year, no? Number of suicide reported in particular city in a year or in a month.
yeah, that is something. So number of faulty blades in a packet of 100, you can say, correct? Here we are interested in space of number of occurrences. I'm not interested whether it's non-occurrences of the events. Another time, you can say, like number of air accident in some unit of time, I can say, or not.
Yes, sir.
Another example I can take, number of car passing a crossing per minute during a day.
Yes, sir.
So you can take like number of car passing a crossing. I mean, you can say
So
there
can
are
I ask
four
one
where,
question
yeah,
related
yes,
to this?
please. Yeah, yes,
Sir,
please.
can it be like for space, can we also consider area and volume? Like number of chocolate chips in, say, in ice cream, or
Number of chocolates in ice cream.
Yeah, chocolate chips in the ice cream. So this is something volume, right? So here also we can use, right? So I'm asking like
Yeah, it's a-
volume or in area also we can use.
For space, I can say, yeah, we can, I think, consider like there,
But
we
the
can consider,
event should keep happening, right? There should be some
yeah,
event which should be happening, like as you
see,
just said, suicide or a car
yeah,
passing. So there
see,
should be some event. It is
No,
not
yeah,
just
that
a
is
number.
okay. The event might be something, but I'm asking like it will, I mean, can that space could be even area or volume also, right?
yeah, it can be. Like, see, let me give the another example. See, as we know, Poisson can be something events occurring. Okay, I'm going to define events occurring in, let's say, fixed interval time. Okay, this is the case when Poisson distribution occurs, right? In the events occurring in fixed interval time. For example, any example you want to tell?
Number of rocket launches from
Okay,
ISRO or whatever.
yeah,
That above example per
in a day and
In,
all things,
in a year,
Or
maybe.
or I can say
can we say
number of,
the amount of rain in a particular day? Or
let's say no, it's about number of occurrences. Okay, let's say
okay.
number of telephone calls received per minute at a call center or at a whatever. So here, what is the things? Events occurring in a fixed interval times. Okay, I'm interested to know what is the number of telephone calls received per minute at a call center. Okay, so I'm interested what is the probability for receiving the 2 telephone calls, kind of things, right? Another example, you can take events like number of vehicles, or this one, number of car passing a crossing or intersection point, anything, right, per minute. So here I'm interested in an interval of times. This fixed events occurring in a interval of time, it's clear. So we'll move to the event of space. It's clear.
Yes, sir.
Okay, now come to the case when events occurring in fixed rather than time. I'm interested in interval of space. So in the space, I have taken the example like this: number of suicide in a particular city. Another example you can take like number of typo error in a book. So book is something kind of space, or you can say number of defects in a wire cable of finite length, right? Number of defects in a wire cable of finite length. So here I'm saying we are interested in number of defects of in a wire cable of a length, right? So here length, here is we are interested in an interval of space. Okay, we can say number of defects per meter in a roll of cloth. Okay, so cloth is something, roll of cloth is also something space.
Sir, can we say number of wickets taken in a over?
Number of wickets in a over. In a over.
Because over is a fixed number of balls.
No. So, but Poisson is something. See, Poisson is something where things are not fixed, right?
Okay. But
Number of tries.
fixed interval of space. That is fixed, no, sir. That in
Yeah, interval of space is fixed. See, if you in a over, I think I need to think, but as per
you
I
need
know,
6. You have in a over you have 6 balls.
yeah,
so,
I have n is fixed, right? There is 6 ball only.
Yeah.
Something.
So this
Number of
doesn't
runs,
come under.
it can be. Okay. Suppose n is 6, you are saying. So at the one ball, so we have to think what is my x. You are saying number of runs. So number of runs.
Number of runs can vary from 0 to 36, right? 6 6 or 36 max.
Yeah. It can be 36, can be,
Yeah,
suppose there is
correct.
no ball, then runs can vary also. It can,
No, I'm asking the space, what you're meaning to say, is it can it be equal, can it be equated to overs or something like that to understand?
yeah, we can say, yeah. Like, see, I think I'm not very sure, but I think as we can say, because number of runs, or instead of run, we can think another thing, right? Something which is like number of runs. Yeah, I think, yeah, number of runs in, we can say, in each over of a cricket match, kind of things, right?
Okay, okay.
Okay, I can think. I mean, I'm not uh, very sure, but I think so.
Okay.
So it's clear. I mean, concept behind this Poisson.
Yes, sir.
Yes, sir.
Poisson.
Sir, I have a question. Well, I mean, till the time Poisson was introduced, we was clear, but when exponential distribution also came into picture, that was also using lambda notation, and it has another formula for f of x for PDF and all. Even it has variance and mean in terms of lambda. So this and that are confusing,
No.
sir.
So yeah, no source. So for the exponential, it's in week 12, right? So for
Yes.
exponential, we know the PDF is nothing but what? First of thing, exponential is the continuous random variable. Exponential is defined for the continuous. Poisson is for the discrete. These two things should be clear for you. Okay.
Okay.
So exponential is something what? Exponential decreasing, exponentially increasing, something like that. So PDF for this is lambda into e raised power minus lambda x for exponential, and x can take value greater
Yeah,
or equal to 0.
just like how you have given examples for Poisson, can you give for exponential also?
Okay. So it's a okay for exponential. Uh, sometimes it's mentioned, right? Like it's the amount of time. Okay. See, as in which week there are
12.
things are missing. 12,
12.
right? Let's say uniform. Okay. Jump. A lot of questions are there. See, you can see that here time required to for an athlete to complete a race. Okay, is exponentially distribution.
Okay.
Waiting time, I mean, kind of amount of time, right?
Yes, yes.
Okay, like here, lifetime of battery is exponentially distributed.
Okay.
Okay.
Okay. Okay.
Got it? So,
Yes.
So
and,
time,
but,
it's all time related questions, is it?
no, you can change the things, but see.
No, whenever some time related thing is asked, you'll have to identify.
And but yeah, you have to identify, but first thing, you have to think whether it's continuous or not. But time is continuous. Okay.
Okay.
Because exponential distribution is defined for the continuous random variable. See, like generally your exponential distribution comes into the picture when suppose I'm interested in the distribution of time. I mean, you can say amount of time, right? Until any specific event occurs. So amount of time, like let's see here, amount of time required until a specific events occur. So until some specific events occur means we are interested in the amount of time until at least complete a race. Okay, is exponentially distributed here. And in the next, you can say lifetime of battery. I mean, amount of time of battery is exponentially distributed until his lifetime is when it get lost. Okay, so it's nothing but distribution of amount of time till then some specific event occurs. Like I can say length of a phone call, right, is exponentially distributed in a minute. And Poisson is number of call received. See, Poisson is, what is Poisson? I can say number of telephone calls received per minute. Now, exponential will be length of a phone call in minute. In minutes, I mean in minutes, in our you can define whatever. But thing is that, are you able to differentiate between these two? These things are this thing.
Yes,
It's
sir.
something discrete. I'm interested in number of telephone call, 1 call, 2 call, 3, and so on.
Yes, sir. The countable thing.
Countable things. But exponential
Here we are measuring.
yeah, exponential is for continuous random variable. Continuous random variable, it can take any values, and it cannot be countable. It's measurement. So length of a phone call I can measure, right? So when amount of time, see, you can relate amount of time until a specific events occur. Is it clear now?
Yes, sir, it's clear.
Clear? Ritik, you got the concept so now?
Yes, sir. Yes, a little bit I understood. And
Yeah, you can you will if you watch the lecture video, things will
yes,
get
sir.
more
Today
similar.
I will complete this.
Yeah, okay.
Sir,
I think
Because
28
tomorrow is the due date, right?
Yes, sir. Yes, sir.
Oh,
28.
yeah, we have extended the due date of graded assignment.
And sir, how many mock will be there for this quiz?
One
sir?
mock, I think you can expect the next weekend. I think
Only
next
one mock
weekend is
full.
3rd December, right?
sir,
So, yeah.
I have a doubt, sir. Actually, in my portal, I'm not able to see any of the live sessions after week 9.
No, after week 9, it has not been uploaded yet.
Okay.
We will
When
upload
will you-
when it will get done. Okay.
Okay.
Thing is that we have to
Because
watch.
week 10 is already the graded assignment and all are submitted. But still the videos are not uploaded.
You are talking about tagged live session, right?
Pardon?
Tagged live session, right?
Yeah, under live
Yeah.
sessions.
Okay. Yeah.
Week 10,
Thing is
week
that
9.
yeah.
It's only till week 9.
Yeah. Thing is that I mean, we have to watch the lecture video and we have to embed the time stamp. So we'll upload it when it gets done. Okay.
Okay.
Yeah.
Okay.
And sir, one question is there, sir.
Where?
Will after this completing, will we get this activity question practice assignment in next term? Means if you want that some
I
chapter to
think
revise.
I think you will have access after the completion of the term. I think
Okay, the activity question, this type of thing will be accessible.
Yeah, you can access. I think so, but I think I need to ask with support. But as far I know, you can access as you are a student of the course we have completed. You can access the thing in later. I mean,
And
I
sir,
need to ask, but I'm not very sure. But yeah.
Okay, sir.
Yeah.
And sir, I have chosen 4 subjects in this first term.
Mm-hmm.
And I listen that everyone say that second term stats 2 is very hard. So what should be strategy? Means what should I do? Means if I get what should I decide to get 4 subject in next term or not? If I get more than 70% in overall or 80%, 90%, is this kind of criteria will be?
The thing is that okay, you are working professional or you are
No, I am full time doing this course only.
Yeah, then I think you can manage. I mean, it depends on the individual things. I mean, some students no are able to manage all the 4 courses and they are performing well. Okay, and some so suppose those who are working professional, so they probably take 1 or 2 courses so that they can manage according his or her time. Okay, some are doing another course, another degree. Along with that degree they are doing this course, so they are according to the time of the person. And you have to be clear with you, whether you are able to manage. If you are managed, then you can take the 4 courses at a time. If you feel
Yes,
I
sir.
can take 1 course, 2 course, I mean,
Okay, so
accordingly.
that's why I am asking, if I score more than 80% or 90%, then I should take course. When
Yeah, there is
what